Good evening, everyone, and thank you for listening to the Futurati podcast, where we dive into how emerging technologies will impact the world and your bank account. I'm Trent Fowler, and joining me, as always, is my co-host, Thomas Fry. Thomas and I are futurists, keynote speakers, and consultants with decades of experience in analyzing trends and communicating new developments to audiences across the world. Reach out to us at futuratipodcast.com/contact-futurati if you'd like to hire us for consulting, to speak at your event, or to advertise on our podcast. Thomas, we just wrapped up a fascinating interview with serial entrepreneur Tigran Petrosyan, who is building a platform for the annotation of data. And just before we hit record here, you were telling me that one of the key things you learned about machine learning and data science was that autonomous vehicles require a lot of annotated data. So what did you feel was the biggest takeaway from this episode? What did you learn that was...
Actually, there were several key issues that stood out that... just training AI is a laborious task, and training it in autonomous transportation. That's why it's taking so long to get driverless cars, to get to that point where the cars are, you can just jump in and feel safe going somewhere, because it has to know what to look for, and somebody has to go in there and actually label all of the things that it's seeing, all of the computer vision, the cameras on it, what it's looking at. Is that a kid running across in front of the car? Is that a gopher? Is it a goat? What is that? And then, or just a ball running across. And then what action should be taken at that point because of that? And when you have, 75 million hours worth of video that you're staring at, trying to analyze, the computer's pretty dumb. Somebody has to go in there and train it all to begin with. And that's where this annotation comes to play. And that I found quite fascinating.
I hope that one of the things that our audience will take from it is just how much goes into training these models. And it's easy from the outside, if you don't build them or you don't know much about them, to feel almost as though they're magic. They're just these vast algorithms that can do these almost incredible things. But somebody's got to go in and label those data. Somebody's got to feed it to them. Somebody's got to train it and load in industrial quantities of labeled examples for these algorithms to learn. And so hopefully on the other side of this interview, they will have a better understanding of sort of the nuts and bolts of machine learning, and they'll have a better appreciation for this phrase I'm always coming back to, that it's math all the way down. Right? There's no magic, right? It's just algorithms. It's only as good as the data you give it. And somebody's got to be responsible for managing all of that and building platforms around it. So that's what we talked about. Hopefully you get all of that and more from the interview. So without further ado, this is episode with Tigran Petrosyan. Tonight we're joined by Tigran Petrosyan. Tigran is a physicist turned tech enthusiast and entrepreneur who is passionate about building comprehensive teams and making products people love. He is currently building SuperAnnotate, an automated annotation tool that helps to speed up the computer vision lifecycle. If you enjoy this interview, please subscribe to the podcast and share it with your friends. And don't forget to check out our website, futuratipodcast.com. Tigran, thanks so much for coming on the show.
Yeah, pleasure to be here.
Why don't you tell us a little bit about your background, your interests, and what brought you to working on the problems that you are working on today?
So yeah, I'm this co-founder and CEO at a company called SuperAnnotate. The company name basically tells what we do and how we do it. We do annotation and we do it super well. My background is in physics. I was born and raised in Armenia, did my physics my whole life. And then after doing my bachelor's, I moved to Switzerland to do my master's in physics. Eventually moved to biomedical imaging side of physics. When I was doing my PhD there, was facing some problems of computer vision, and eventually got deep into understanding how computer vision can basically transform the whole radiology part of the business, making sure radiologists do their work better diagnosis of different diseases with computer vision. Of course, it's a huge problem, still a lot of problems in research, but I got fascinated by that. I was giving some TEDx talks across Switzerland at the time, And lucky enough, my brother was working on image segmentation technologies for computer vision and build a very kind of image annotation tool, simplistic tool with his tech that was accelerating a very specific annotation task called semantic segmentation that attracted a lot of attention from competition at the time. Like Scale AI CEO wanted to buy the tech and some of the other big players. We got quite excited about this opportunity and we decided to do it ourselves. So we dropped out of our PhD programs and started a company called SuperAnnotate, first very simplistic annotation tool for computer vision, and then eventually became fully fledged data infrastructure for AI, starting from annotation piece, collaboration of data scientists, engineers, annotators, reviewers, all working together to build high quality training data at scale, and then building the workforce marketplace to bring the right people to annotate actually the data for our clients. And then ultimately, once the data is labeled, we help our clients to make sense of the data, understand what to label next.
So give us some examples of who your client base is. I mean, just what industries do they work in?
Yeah, I guess one of the most obvious examples is the autonomous driving industry, where every day they're driving thousands of miles in the streets and labeling all that data. So we're labeling a lot of data from the streets, like cars, human lanes, etc. There are other like maybe less obvious examples, like for insurance, for example, I don't know, you want to estimate roof damage or car damage with computer vision. And there are tons of other examples in aerial imagery, let's say the drone flying through the fields and telling how the crops are doing and where the diseases, etc. I mean, it's just some simplistic examples, but applications are really very widespread. Healthcare is another big industry we're in, where, for example, in one of the applications we work, we help our clients to do a very good human pose estimation that helps with online therapy, like an online therapy platform, kind of helping clients to get better at their exercises.
Hello, this is Trent Fowler, co-host of the Futurati podcast. One of the most common pieces of marketing advice I've come across is to know your audience and give them what they want. One difficulty in podcasting is that it's actually pretty hard to do this. None of the major platforms give us any way to reach out to you, our listeners, to find out what you enjoy about the Futurati podcast and what you'd like to see done differently. So we've decided to record this commercial and ask you directly to reach out to us. Head over to futuratipodcast.com, go to the contact page, and drop us a line. Tell us about your favorite and least favorite episodes, what you'd like to see us cover in the future, and anything else you want us to know. We produce this show for you, and we want your advice so we can make it even better. Thank you.
So I think a lot of people listening to this would not appreciate why annotation at scale is valuable at all. So could you briefly walk through why that's such a big deal and why it really matters as a crucial component of the overall data infrastructure?
Yeah, absolutely. So, I mean, every day we hear this fascinating applications of machine learning AI, like ChatGPT probably is the most widespread known lately, but there are tons, right? We talked about autonomous driving and, Alexa is listening what you're saying and, there's sentiment analysis from text or your voice or, so for all those applications, it seems magic, but what drives this innovation is actually the data behind. The data, what is helping these machine learning algorithms, these models to learn. And by data, I mean annotations of thousands to millions of images, text data, audio data that is being done iteratively. And each time you iterate your model, you expect your model, as so-called, to perform better. For example, to identify a car in the street with, 95% accuracy, and then 97, 98. Each time you want to increase that accuracy by 1%, 2% at the end. Sometimes you need even more data to label than before you get to that level. And it's not just how much data you label, but also what kind of data you label, understanding where your model doesn't perform well and really focusing on that edge cases. And then another key part is what exactly you label, how you understand the mistakes of labeling when you do it at scale. So these are a lot of problems when it comes to the data labeling, and this has kind of created multi-billion-dollar industry already that is growing 20% year over year. There are actually millions of people who are doing this full time. Sorry, go ahead, please.
Yeah, I'm assuming your annotations are searchable then. Is that correct?
Yeah, I guess once you do the data labeling within our platform, everyone can kind of query, for example, show me all the, I don't know, pedestrians I've labeled, were, let's say, forward facing or backward facing. Based on the project instructions, you can always search, find, and that kind of helps to really deep dive into specific annotations and understand how your model performs.
Yeah, let me step in and just provide a little bit of context for the people who aren't machine learning engineers. So if you're trying to build like a neural network that's able to classify flowers or something like that, you have to show it examples of labeled images. And then it learns a mapping between the pixels or the colors in the flower, the shape of the flower to the label, right? You can't just feed it a bunch of images and say, go figure it out. Like it wouldn't know what to do. So it's got to see a lot of examples of the right answer. And then if you've done it correctly, then it will be able to generalize to new images that it's never seen before. So you have to feed it lots and lots of images, which are labeled correctly in order for it to learn the underlying function at all. And the problem you're solving is that annotation piece, is getting all of those images, right? So you might have 50,000 images of flowers on your hard drive, but those are useless unless they have the labels too. And someone has to put those labels in. And some of these, especially larger models, you referenced ChatGPT earlier, take a gargantuan amount of data. And sometimes shaving off the next little bit of accuracy, or shaving on, I guess, adding 1% more of accuracy might take 80,000 more images or something like that to get from 96 to 97 to 98 and going on like that. So there's a lot of work involved in getting those images, annotating them correctly, managing all that, version controlling it. It's this big unsolved problem in data. These applications are incredibly data hungry, and you're part of the plumbing that allows us to feed that monster and get it to learn new things.
Yeah, that's such a perfectly explained example. I mean, you brought ChatGPT as a very prevalent case where, for example, you write a question and gives you a very nice answer, right? And then sometimes we forget that behind that, there were so many similar questions asked, and the answers were ranked by some people, whether it was right or wrong. Those people also kind of made sure that there is no graphic answers or no answers that was bad for humans to see. And this was actually, a lot of behind the doors work, which was this annotation, data, all this management. Nicely described, Trent.
Yeah. Well, and in that one, they also used RLHF, reinforcement learning, and human feedback. So there's like a whole extra layer on top of it of producing these answers, and a human being has to do it. Somebody has to go in and do it. So why don't you tell us a little bit about the actual platform you've built? Feel free to get into some of the technical details, and let's talk a little bit about SuperAnnotate.
Mm-hmm. So when we initially built a platform, the tech that we had it very unique. It was a platform that would identify the edges of the objects very accurately right away. And then the labeling of those objects become just one click. That was kind of a starting point. But eventually, as we built the platform and expanded, we identified a few very key problems in this space. First is how you build high quality data at scale. By high quality, I mean, imagine if you have millions of images or audio files. If someone tells you to label every single car or human or lane in that image, our experience shows, or generally experience shows, that people do a lot of mistakes. Models are doing a lot of mistakes, and every mistake can actually affect the model performance quite dramatically. And how you make sure that you have the high quality data. That this is first what our platform provides. So imagine you have a million images. You send to our system. It automatically goes through hundreds of people, They get the instructions what to label. They label those, whether they put a little box on it or through the edges of every object based on instructions, what the customer wants to do. And then this data goes to the next stage, the reviewers. So it automatically has a system where it goes to the reviewers. They check the quality of the labeling data. They see where the mistakes, communicate back to the annotators, or send it, correct it, and send it to the next level, maybe next reviewer, or the administrator who was giving a more holistic view of the data and understanding any kind of next level quality issues, or what data has to go to the pipeline or not. Sometimes there are data engineers. And then ultimately, once everything is correct, the data that is being finished and labeled goes back to our customers' pipelines, machine learning pipelines. Maybe I can share more about what it is, but it's basically a system where you run models, iterate models, try to get some parameters, understanding how your model performs, and do that in an iteration. Then once that data goes to the pipeline, basically the models are run, and then you have this matrices, the models that kind of helps you to test how your prediction works after your model is built on that data. So this is one key piece of the platform. Create that infrastructure where millions of data can be labeled collaboratively by different roles of people working remotely anywhere you want.
So can you imagine a time moving forward where you've labeled practically everything and you no longer have to do the annotation anymore?
Yeah,
we ever get to that point?
Yeah, this is currently a very hot topic, how you automate the labeling and make sure that all the data is automatically labeled. And if we do that, basically we have solved all the machine learning problems. So there's no need for labeling anymore. The interesting problem is right now, how you at least automate some part of it and make sure that human is only focused on the parts of the images or other data that the model doesn't perform well. So that's a very key part of what we're providing with our platform. We also help clients to understand what to label, something called active learning, what to label that will affect the best to the model performance, because not every data is helping to improve your model. So there's a famous, saying in the space: if you have garbage in, you have garbage out. Garbage in terms of the data. So you have to make sure you're labeling the right data, high quality data. So that's kind of a big direction in our space, how you automate more and more data. And at some point, of course, it's an interesting part, right? A lot of data is created synthetically, being created as labels. A lot of data is being manually labeled or automatically labeled. So it all comes together in a combination to build high quality models. At some point, more and more data is being labeled automatically, of course, but the problem also comes with the problems that people solve in machine learning are constantly changing. So the data that you were using to build some kind of machine learning problem is absolutely sometimes not usable to do even a close similar problem with a different camera or resolution of the camera, a different angle. So sometimes you have to start from zero. So this problem seems to be never ending so far.
Are you enjoying this episode of the Futurati podcast? If so, please like it, give the show a 5-star rating on Apple Podcasts, Spotify, or wherever you get your podcasts, and share it with your friends. By far, the best way to help us grow is to spread the word on social media, which will expose our content to more people and help us continue to bring you interviews with world-leading experts in AI, quantum computing, cryptocurrencies, and so much more. Thank you in advance.
Yeah, I'm not terribly worried about running out of stuff to annotate. Tell me a little bit about your efforts to automate the process and what that looks like. How much of it is automated? What sorts of tasks are easy to automate, and how the outsourcing platform part works?
So to automate, sometimes you just need quick quick sample of data sets. Let's say you label 100 images, you run a simple model, and the next 100 will semi-automate it. You see where the model doesn't perform well, and you correct only those parts. So it's kind of semi-automated. Another way is you tell your system to only annotate the images or data that the confidence score of the model is less than, I don't know, 90% or 95%. And this is where you also only annotate a small part of it, and the rest is automated. Big debate currently in our space is who should own the model, right? Because customers really want to own the model, and we don't want to run models on behalf of the customers when they have actually the best models.
Mm-hmm.
And what we do is usually we set the output of their model, which is sitting into their pipelines, in their clouds, the output of their model into us as pre-labeled data. And then we basically correct some small portion of it to make sure that their model is what is being based to automatically label, instead of us providing the labels. And this seems to be working with many of the customers we're working currently.
So they train it, and then the model outputs labels, and then you correct it to semi-automate it. So you're just correcting a machine's output as opposed to starting over from scratch, and then that's sort of in a feedback loop.
Exactly. And then we set a system that this whole process is automated. The data inflow, outflow, what is being labeled, it's a super slick system.
So how do
You would say that.
how do you price your service then? Because part of it is letting the customer do the work, and part of it is you doing the reviewing. How do you price that for customers?
Yeah, so we are platform first company, right? So what customers need is, whether it's a label data, they first buy the platform as a subscription model. And then based on how much data they need to be labeled, whether it's how many hours of workforce it was being used or how many labels has been created to our platform, they're being charged in addition on top of the platform. So this is kind of a model of, combination of usage-based plus subscription that kind of helps to really make sure that we as a business, SaaS business, software as a service, can really grow in terms of, more data being labeled, more workforce we're incorporated in, or whether more technology we're using to our system. But on top of that, what we've built is this ML Studio part of the product. So once the data is labeled, we help our customers to really get the right analytics, understand how this data is helping to improve their model, and what are the biases, how they version those data sets, etc. And this becomes a really key piece as a solution we have in order to kind of drive future growth of us. So no matter how the data is labeled, we have this infrastructure that helps clients to really manage their data.
So I'm pretty sure that there's going to be somebody listening to this podcast that's saying, wow, I think I could have a good career as a professional annotator. What kind of background would I need to be good at this? And then what kind of salary could I expect as a professional annotator?
Yeah, in fact, there are millions of people who are actually working full-time and part-time doing this job. Most folks are in Southeast Asia. Of course, a lot of people are in the US, depending on geography needs, in Europe, security needs, etc. It very much depends. For example, there are a lot of doctors annotating, for example, right? You need the right skills to look at biomedical images, and then kind of do the right diagnosis so that machine learns. Sometimes you need very specific examples of, I don't know, like where are the damages in chips or in machinery, right? So as an annotator, like in a very high level, anyone can become an annotator, because there's so many simple projects that are just like identify. I mean, I'm giving a simple case, right? Where are the cats and dogs? Where are the cars or humans? Or So this is simple and it's so easy to do. But of course, there can be very complicated cases that requires a specialty annotators. And this is what's exciting about our marketplace of labeling teams that we have created, because we know which team has which expertise. So anytime the client come to us and says, hey, I need annotators who need this kind of expertise, we will find them and we'll bring them into our platform and manage and guarantee the quality of that data.
Talk to me a little bit about ML Studio, because it sounds like you're shading over into observability and introspection of the models, and that's a really hot topic as well. Understanding how a given piece of data is being used by the model, how it's modifying the internal weights and all of that. So I'd like to hear more about that piece.
Yeah, for sure. You have somewhere sitting, let's say, millions of data that is being labeled. So as a data scientist, or data engineer, you really want to have a holistic view of that data, get the right analytics. For example, I don't know, show me all the cars that is looking from behind and compare it to the model that I've just run and compare it to the first 100 images that being annotated by this person, whatever. I'm just giving random example. And from that, you're kind of getting the first level overview about how your model performs. Where are the cases that your model didn't run well, or what are the type of images you need to label next in order to improve that? That's a very easy first step. Having the holistic view about your model performance and the data set on specific edge cases. Second key part is, really comparing one model performance to another on the same images. For example, I've built multiple versions of your model and they perform differently. Let's say I took 100 images and I said, hey, this model, please predict people that are size of 10 pixels or less. And then there's another model. And then you put on top of each other and see which ones are really predicting that well. And then from that comparison, you can say, hey, this model is better than this one, but this model can be better on some other objects than this one. So that gives you a right idea how your models are and what you need to do to improve both on different ways.
So are you looking at patterns of activation inside the models, or is that more detail than you're getting into? Because it would be interested to know, I would be interested in knowing, so you've got 5 different versions of a neural network trained on different subset of the data. I would be interested in knowing how each one is actually processing the images as you go through. With something like a convolutional neural network, you can look at the how the convolutions are actually arriving at different abstractions in different layers, and then that's very fascinating work. And then that gives you some insight into what the models are actually doing with the data. And I wonder if ML Studio is capable of doing stuff like that.
Yeah, so there are multiple parts of the MLOps pipeline. We're looking at the models from the data side. So how it affects the data and what to label. There are many different platforms that are specifically looking at like model parameters, trying to look at some other model related stuff, but that has not much to do with the data, but model itself. We're more data focused, but there's so many platforms that are trying to handle other sides that we're kind of tightly integrating. If customer wants to have all that system set together, this is what we provide also. As the time passes and as we grow, of course, data itself is already a huge tackle. So eventually we may potentially try to tackle other model related areas, but right now we're heavily focused on data related matters on the model.
What sort of data augmentation do you support?
So that's a good question. One of the areas we've been exploring a lot and build a tool set around it is finding the edge cases. For example, right, like we realized that our model doesn't perform well in low light conditions. We can generate similar type of data sets through our platform through, this generative AI, it's a fancy term, but we try to integrate that into our systems that instead of going back and taking similar images or videos, we just generate similar images and then we label. Sometimes it's auto-labeled and if needed, also manually labeled. And then feed back to the model and kind of trying to see whether the model improved. And if it's not, then try to generate new. So this is a very interesting way for us to kind of look at this problem.
So how long has the annotation industry been around? I mean, when did it first get started, and how do you see this evolving over the next couple decades?
Yeah, that's a very good question. It started roughly about 20 years ago with this early rise of machine learning. There was a structured data like tabular data for example, financial time series. And this gave rise to this crowdsourced workforces when there was no ML expertise actually in these workforces that gave rise to this, companies like Amazon Mechanical Turk or Appen or Linebridge. So they're huge workforce companies. They would just do any mechanical task, like vertical annotation shops. And then there was this second wave that started roughly 7-10 years ago when the machine learning algorithms got better and better on unstructured data, like images, videos, text, audio, etc. And that gave rise to this enterprise ML companies and then data labeling companies that were solving some specific specialized annotation problems for those companies. I think this was the time when Scale or Mighty AI that was acquired and some other labeling companies came in. And now, as we have grown a little bit more in the last few years, starting from 2020s, the data centricity of AI became a prevalent driver. And that gave rise to the companies like us. There was a Labelbox, Snorkel. This gives rise to this new generation of AI companies that are just heavily relying on the data and its management and its automation and its workflow, custom workflow systems, etc. So just I kind of probably tried to give a little bit more wide overview, but these are the three waves. I think ChatGPTs will bring another huge wave to this and another huge acceleration of what's going on here in the data-centric AI.
So can you talk a little bit about how the nature of data itself is changing? I mean, getting data from sensors is different than getting them from video cameras, and that's different than radar or LiDAR. And what kinds of challenges do each of those different forms of data present to you?
So yeah, there are so many multiple data that is being labeled right now from different sensors. I mean, if you think about camera itself is also a sensor on just the visual data. That can be 3D like LiDAR sensor, etc. So for the data can be also like from social media, it scraps some information and then labels. Anything now can be labeled, and you have now machine learning algorithms on any type of data to learn and do some prediction and analytics. So we're living in this very exciting time that it's not just structured data, but any data can be labeled, but each has its own challenges, you're right. And of course, for example, computation for images to predict an object became so cheap that now it's running in so many devices already, even on smartphones. Of course, once you get to the 3D data like LiDAR or radar sensors, it gets a little bit more complicated. You already have to label 3D objects or points in a 3D area. It adds basically the size of the models gets much bigger, and in order to run it, you need more GPU power. On text, it also got super cheap for NLP applications. I mean, ChatGPT, as you know, it's so cheap just to type a question and it just immediately answers in a very cheap manner. So all these applications are evolving, and nobody knows what's coming in 1 year, in 2 years, in 5 years. That's a crazy part about what we're into right now.
So I've been speculating on this idea of having a AI radio that just plays songs for you that it's making up as it goes, and it's automatically reading whatever your expressions are, what your feedback is. And so when it spots something that it knows that you're not interested in, that you don't like that song, then it switches to a new song that's more upbeat and something that meshes with your mood at the moment. Is that something that's going to take a lot of annotation leading up to getting it right?
Yeah, I'm sure right now that the technology, everything is there to do that. I think in a simplistic manner, already looking at what your how long each song you're listening, there's a machine learning algorithm that totally understands what your preferences are and will give you the right songs every time. But when it comes to really understanding your mimic expression, the technology is there. It's just someone has to put a camera and then understand what your emotions are. And I'm not sure if there is a solution right now, but the technology is there. Similar thing, I had friends who were building some solution from web camera, for example. They could identify, looking at certain videos or images, how you feel, and then based on that, they would maybe suggest, they would understand what kind of ads to show, or what you like or you don't like. So this emotion detection is in such a high level. I mean, it can detect whether you're smiling, what mood you are. It's incredible, the technology already on that side.
Do you need a dynamic and knowledgeable speaker for an event? Thomas Fry and me, Trent Fowler, are both seasoned keynote speakers, able to converse on a wide array of topics to audiences of all sizes and skill levels. Go to the contact page at futuraudiopodcast.com to book Thomas or myself today, and let us apply our years of experience in public speaking to make your event a smashing success.
I wanted to circle back around to an example you used at the top of the show, and that is radiologists who are doing very specialized image annotation. I can't recall the exact timeline, but I think it was 7 or 8 years ago, one of these AI luminaries, it might have been Jan LeCun, said that we should stop training radiologists because there's not going to be any need for their services in the future. And as an industry insider, I was wondering if you'd weigh in on the topic of technological unemployment, because this is on a lot of people's minds as we're watching ChatGPT crank out sales emails and tweets and blog posts and various other things. I do content creation and SEO and copywriting myself. So I'm looking at it like, wow, is there even going to be anything for me to do in a couple of years? How do you think about that? I mean, are you seeing any trends in that direction that worry you? Or are you completely unconcerned with it? Where do you come down on that?
Yeah, that's a very good question and big worry, of course, across the world. This happened also in many revolutions happening, industrial revolution. People in the farms would really worry about, the factories are taking our jobs, but then people move to the factories, and eventually, taxi drivers, right? Like eventually, if they're autonomous cars, they will not be taxi drivers. And of course, technologies, other AI technologies like ChatGPT, I think now the sense is that the person who knows how to use AI is going to replace the job rather than AI replacing your job. So right now it's super critical to kind of get familiar with these technologies, because you have to use those. It's like, I don't know, in 80s, there's computers coming and people say, oh, computer is going to take my job. And there were so many simple tasks people were doing or filling out some things. So it was taking so long time, right? But then people started using computers, and suddenly those who can use computers shift to other type of jobs. Like, for example, who would think like 20 years ago that SEO will be a significant job category. So things are very heavily evolving, and it's much faster now than any time before. And that's my worry, that that transition is happening too fast, and the adaptation pace can be a little bit hard. Education system is so outdated that it's going to be so hard to keep up from the educational perspective. This is my biggest worry. But other than that, after some time, I feel like it's just going to help us to be much better and more efficient to what we're doing. And for example, right, we have so much free time, we can do things we love, that 100 years, 200 years ago, people would just spend so much time at working in the fields. And I feel like there can be another jump in 5 years, 10 years. But within that time, there'll be some disruption that the adaptation can be maybe painful.
Yeah, technological unemployment is a hot topic. And it looks to me like people are going to set their sights higher. When you're working, you and a piece of automation, you can accomplish 10 times what the average person today can accomplish in their lifetime, or you can accomplish 100 times or even 1,000 times more in your lifetime than somebody could 10, 20 years ago. So I think we're going to start seeing people set their sights higher, that they're going to set out to accomplish so much more over a certain period of time. And that becomes the massive game changer that people haven't been anticipating. That's what it looks like to me.
Exactly. Yeah, there definitely is going to be some kind of heavy disruption, and people have to adapt, adjust. My ideal like world case scenario is, because we have so much more smarter machines that are making us more productive, there'll be better laws that will let people, let's say, work, I don't know, from 8 hours per day, maybe 6 hours per day or less, while all the technology and gains will make sure that you benefit from it and have a better quality of life while working less and doing what you really love. Of course, this sounds like too idealistic, but all the technology is there that can potentially get us there.
I think that is a nice optimistic note to end on. Is there anything you would like to leave our audience with as we close up here?
Yeah, my last notes are just anytime we don't know something, we tend to kind of get afraid and freak out. I think instead of that, it's always good to kind of try to learn, and once you learn, you understand more, of course, how that can help you, and then you start getting afraid less. So never stop learning, especially on AI and understanding how AI machine learning works. And this will be the best thing that will happen to you in the next several years to come.
Learning is the antidote to fear. I like that a lot. Thanks so much, Tigran.
Thanks, Trent. Thanks, Thomas. Great chatting with you.
Thank you.